Hello, this is part B of our 2026 chemistry practicals class. So the first class we talked about the use of dilute sodium oxide to test for metallic ions. Exactly. Today we are going to look at aqueous ammonia. Using aqueous ammonia to also test for metallic ions. Exactly. So remember, we are given certain reagents for our qualitative analysis, and we are using each of the reagents in our simulation class to look at what you should expect. Exactly. Then after doing that, we will now simulate the questions that will come in exam. I've simulated 3 questions on qualitative analysis that will come based on the instruction materials provided. So don't miss any of the class. Exactly. Don't miss any of the class. So aqueous ammonia. We will still do what we did last time, ions, observations in drops, and in what? Excess. Observations in drops and excess. So lead 2 plus, a white precipitate in drops, which is still insoluble in excess. Do not forget that this lead 2 plus was soluble in excess when we use what? Dilute sodium hydroxide. But it's now becoming what? Insoluble in excess when we are using what? Aqueous ammonia. Are you following? Good. 2. Aluminium 3 plus, white gelatinous precipitate, like a gel. Okay, it's like a gel. White gelatinous precipitate, insoluble in excess, aqueous ammonia. But in drops you're seeing it. I see a precipitate was formed. So what we say a precipitate is formed means that the precipitate, the salt is insoluble. Are you following? So we'll see test further by adding excess to see whether to dissolve or not. And it still did not dissolve. Then we have copper 2 plus. The color of the solution will light blue. Okay? In drops, when you're adding in drops, the color of the solution changes to light blue. But you add in excess, the color becomes what? Deep blue. That's a complementary test for what? Copper 2 ion in solution. Then we have, let's say we have zinc 2 plus. It's a white precipitate that is what? Soluble in excess. A white precipitate that is what? Soluble in excess. At first it did not dissolve. You saw particles, but when we added more of it, it now dissolved. Ag plus. Now silver ion, a brown precipitate, in excess aqueous ammonia, color disappears. Brown color disappears. Take note of that. The brown color disappears and the PPT what? Dissolves. Precipitate what? Dissolves. Are you following? So, when we use dilute sodium oxide, please note, for silver ion, okay, brown precipitate was in drops, yes. Then in excess, it did what? It did not dissolve. It was insoluble. It did not change color. Please take note and make correction in that previous video. So, silver ion, brown precipitate, insoluble in what? Excess sodium hydroxide. But now when we are using aqueous ammonia, this is a brown PPT will form in drops, but in excess, the brown color will disappear and the precipitate that dissolves. Is that clear? Good. So, what ion again? Ion 2 plus, still dirty green, that undergoes oxidation will change to what? Brown, if allowed to stand. So it is still what? Insoluble in aqueous ammonia. Then ion 3 plus plus there is reddish brown, which is also what? Insoluble. Then calcium ion does not form a precipitate with aqueous what? Ammonia. Please take note of that. Calcium ion does not form a precipitate with aqueous what? Ammonia. So these are the ions that will test using what? Aqueous ammonia. We've also checked for soda oxide. The next reagent we will look for, we'll test for the halide, we'll test for the negative radicals like the sulfate ion, the carbonate ions. Are you following? They also do tests for gases. Are you following? We do tests for using what? Hydrochloric acid, because all these reagents they are provided. So please stay glued to this page. We are going to break down everything to you. Before your practicals next week, we'll break down everything for you so that when you're going to your practicals, you go prepared. You go prepared knowing what to do at every given time.